The second thing is phase wound rotor. Phase wound rotor is nothing but the same arrangement. Constructions are same, but in the rotor, the three phases are not short circuited. The three phases are not short circuited. See, here the rotor winding is there, but it is in star connection. So the three phases are not short circuited. Okay, and see, the R phase is connected with one slip ring and it is connected with the external resistance. So you can add external resistance. Suppose if you want to vary the speed, or if you want to vary the EMF produced in the rotor conductors, you can add external resistance. You can add external resistance. But in the case of squirrel cage rotor, you cannot add the external resistance. And these are all the slip ring arrangement. Okay, external resistance. This is the main difference between the induction motor and the squirrel cage induction motor and the slip ring induction motor, the stator rotor resistance. And the other things are, yeah, when you are comparing with squirrel cage and slip ring, squirrel cage is most extensively used because of the arrangement. The construction is very simple. Here we have to arrange some external resistance also, so the circuit diagram will be complex. And squirrel cage induction motor, it is very cheap, but here it is very expensive. So these are all, and then higher starting torque is provided, is able to achieved by squirrel cage induction rotor, but in the case of slip ring induction rotor, it is not possible. It is not possible. Okay, so slip ring rotor, it is also called as slip ring rotor because the three phase windings are there and it is not connected to the so the difference between squirrel cage and slip ring rotor. See, this is the normal induction motor. Here we are having the three phase. This conductors, if it is shorted and made as single winding, then we will have a squirrel cage arrangement. But in the case of slip ring, we are not shorted the three phases. R is different, Y is different, B is different, and we are getting in the output. So this is the difference between squirrel cage and slip ring. So principle of operation of the induction motor. Okay, I will draw the picture in the next slide. Please see it. Okay, now according to the induction motor principle, we are having the stator. The stator is nothing but the stator poles with stator windings, correct? Okay, this is the stator poles with stator windings, and here we are having the stator winding, and this is given to the three-phase supply. Okay, we are going to convert the electrical energy into mechanical energy. So suppose when the three-phase supply is given, there will be a flow of current, and this current is flowing through the magnetic pole, north pole and south pole. Okay, which in turn produces the magnetic flux passing through the air gap between the poles and in the side line also. So this magnetic poles is revolving, this magnetic flux lines is revolving with a speed. That speed is called as synchronous speed, and it is given by the formula ns equal to 120 f over p, where f is the frequency of the supply. Normally the frequency of the supply is 50, and p is the number of poles. how many number of poles we are going to use. The number of poles will be always even number, like 2, 4, 6, 8, like that, because if there is a north pole, there will be a south pole. If there is a north pole, there will be a south pole. Okay, this is south pole and this is north pole. So when the flux is given, when the supply is given, the magnetic flux in the stator core is rotating with a synchronous speed of ns equal to 120 f by p. At that time, this magnetic flux is coming in the rotor conductors. Okay, this is the rotor. This is the rotor, and in this rotor we are fixing the rotor conductors. Okay, here the rotor conductors are passing through the wire. Now this magnetic flux lines, when it cuts the rotor conductors, there will be a electric field produced. That is called as rotor current. That is called as the rotor current. Okay, the rotor current. Okay, now what is happening? Each rotor conductor is having two fields. One thing is the magnetic field. From north pole to south pole. So from north pole to south pole, it's coming from top to bottom, from north pole to south pole. And another field is the electric field. The same conductor, rotor conductor, there is a electric field which is also flowing in a closed circuit, because always current flows in a closed path, so circular path, so which will be traveling from the lower potential to the higher potential, like this. Okay, now what is happening? Each conductor is having two field. One thing is the magnetic field, another thing is the electric field. Another thing is the electric field. These two fields act together. Interact together. Okay, so in the left hand side, both magnetic field and electric field are acting in the same direction. So here this field will be very high, and in the right hand side, magnetic field and electric field are less. So the field effect will be very weakened. So this stronger force of the fields will push the rotor, and this rotor starts to rotate. This is the working principle of induction motor. It is given in the previous slide. When first step, you have to give a three-phase supply to the stator winding, and hence there will be a synchronous speed produced, ns equal to 120 f by p. And this synchronous field, this magnetic field, rotating magnetic field, will make a current to flow in the rotor conductor, and the rotor conductor will experiences two fields, magnetic field as well as the electric field, and these both are acting together, and it pushes the rotor to rotate. This is the operation of induction motor. Okay, so induction motor, which is always runs with a speed lesser than the synchronous speed, because we started the synchronous speed of the stator field coil is ns equal to 120 f by p. Okay, and after there is some relative velocity between the rotating magnetic field and the rotor conductors, and this is the actual speed of the rotor. This is called as actual speed of the rotor, and it is always lesser than the synchronous speed. Synchronous speed will be always higher in induction motor. So the difference between the NS and NR is called as slip. The difference between the NS and NR is called as slip of the rotor. Okay, and the actual speed, suppose slip is given by the letter S, and see, if you remove the proportion, that percentage symbol, NS minus NR is equal by, sorry, this is NS, not NR, this is NS. Okay, so if you cross multiply, you will get S into NS is equal to NS minus NR. So if you take NR this to the other side, it will become positive. So NS is common. So NS, the actual speed of the rotor is given by NS to 1 minus S. Slip speed, and the actual speed of the rotor is given by NR is equal to NS into 1 minus NR. Oh, sorry. Formula is wrong. 1 minus S. So slip always expressed in percentage. In the problem, if it is given as 4%, you have to divide the slip value by 4 by 100. Okay, when S is equal to 0, what will happen? So NR is equal to, if S is equal to 0, NR is equal to 0. At that time, the rotor will not work. Okay, the rotor is standstill. If S is equal to 1, what will happen? 1 minus 1, 0. 1 minus 1, 0. So at that time also NR will be 0. So between S equal to 0 and S equal to 1, your slip value will be existing.